All right, so you don't have to write this down. Just stay with me. If I give you x minus 4 squared, does that equal x squared plus 16? No, this does not equal x squared plus 16. We know that we don't just square both of them. But there is a pattern to this, and the pattern is important. Like if you don't know some of the shortcuts, it's not the end of the world. You could do things the long way, but then at the same time, you're sometimes just wasting time. So if I want to actually square this out, yes, I can do x minus 4 times x minus 4, and I can do the box or FOIL or whatever. But really, this just ends up being x squared minus, okay, so you square this one, and then you double this, so we get negative 8x, and then you square that plus 16. See how easy that is? Which means you should be able to recognize it going the other way. So if I gave you x squared plus, can't even write, plus 24x plus 144, and I wanted you to factor it. There's no reason to go through and try and find factors of 144 because there's lots of them. But if you can look at this, and if your last term is a perfect square, then you check the middle term. If you can take half of this and square it and get this number, then guess what? This is just x plus 12 squared. Okay? So that is a pattern that you've learned in Algebra 1. I'm sure you did it again in Algebra 2. So I'm just reminding you that it exists because it can simplify your life for sure. Okay? We good? And then you can factor it the long way. But if you factor it the long way and you end up with x plus 12 times x plus 12, okay, then make sure that you end up writing it like that. Okay? Because it's going to make a difference in the end as well. Okay? Yes, you should always like condense things as much as you can. All right, so let's look at what we're doing now. This is going on page 39. It is zeros, linear factors, and multiplicity. Okay. Oh, good Lord. Okay, so the x-intercepts of a function are also called the zeros. Okay, that's no big shock, right? And that's not a secret. But we can call them the zeros. What else can we call them? The solutions. What else? Starts with an R. Roots. Okay. Zeros, roots, solutions, x's. Okay. No. All right. So a polynomial function, degree n, can have at most n real zeros. So the key here is real zeros. Remember when you were doing quadratic formula and you would get imaginary numbers? Yes? So that means that those, you had roots, but they were some imaginary roots. They weren't real zeros. So we could have an 8th degree polynomial, but it only have 2 real solutions and the rest be imaginary or whatever. Okay, so an even degreed polynomial, so like an 8th degree polynomial or a quadratic or a quartic, has an even number of real zeros. So that 8th degree polynomial, it could have 8 real zeros, it could have 6, it could have 4, it could have 2, but it can't have 5 or 7 because it's going to have an even number of them. An odd degree polynomial has an odd number of real zeros. And again, we're talking real zeros here. So if you look at this over here, you've got 3 zeros, yes? All right. But that doesn't necessarily mean that it is a cubic, because here is a graph that looks very similar to that, right? We've got, it crosses the x-axis 3 times. Looks like maybe it should be a cubic, but it's not. And here's the cubic part of it, but it's too big for my. So it's actually this times this. So it's actually a quintic, right? There are 5 solutions, but only 3 real ones. Because if I set this equal to 0 here, this is going to give me x squared equals -1. So x equals plus or minus the square root of -1. So those are my imaginary solutions. Okay, so don't assume just because you see 3 zeros that it's going to be a cubic or anything like that. But it is an odd. You would know it would have to be an odd number anyway. This is called Desmos.com. Have you used it before? Okay, some of you may have before. If you've never used it, it's DE. Let me write it over here because I can't write on that screen. Desmos. You might want to write this at the top of your paper. Desmos.com. And if you just type it in and then hit start graphing, You can type anything in, any graph you want. It's really user-friendly, very user-friendly, way easier than using a graphing calculator. Because on a graphing calculator, there are so many settings you have to go do in the window and this and that. You're able to control this a whole lot more. I would suggest, because we are going to use this for some activities that we do, you can create an account. You could probably continue with Google and use your district account with that too. But go ahead and do that so that you have an account, because when I have activities that you go through, if you don't have an account, then when you shut it down, you would have to start from the very beginning. Okay, so this is just like free graph. You can do whatever. You can do tables. It does all kinds of things. But then there's also activities that it can kind of step you through. So if you do play with it some, you can save graphs in there. Just go ahead and get your account made, and it'll just make your life a little bit easier. But yeah, it's a great tool for you. All right, so linear factors and solutions. All right, so the solutions to the equation f of x equals 0, basically when you take it and set it equal to 0, that's how we factor and stuff, are the zeros of the functions, right? Solutions, they're the zeros. They are also called the roots. Here's where all those different words come in. So you just need to know that those are all kind of basically means the same thing. Okay. So if x equals c is a solution to the equation, then x minus c is a linear factor of the polynomial function. Okay. And linear factors can be found by factoring. That's why they're called factors, by the way. Okay. All right, so let's take this example here. So we're given this, I'm going to rewrite it over here. This is x cubed plus 5x squared minus 24x. Okay, so when we go to factor something, what should we always look for first?
Greatest common factor.
Okay, good. And what is that here? X. So I get x, and then that leaves me with x squared plus 5x minus 24. Then I'm going to be able to factor that into two binomials. Since this is negative right here, that tells me my signs are opposite. So I have a plus and a minus. So I need two numbers that multiply to give me 24 and subtract to give me 5. Positive 8 and negative 3. Okay. So right here, this is equal to x times x plus 8 times x minus 3. So the next question says, what are the linear factors? Like, that is the factored form. The linear factors are x, x plus 8, and x minus 3. Those are the linear factors. Okay, there's commas there because I'm listing them. So then from that, and I'll put parentheses here because I don't know, it just makes me feel better when they're there. What are the zeros? So the zeros are when you actually, okay, but what's the smallest one? Negative 8, and then 0, and then 3. Okay, so those are the zeros, those are the linear factors. Make sense? Vocabulary here is important. Like the skills I know that you have, but you got to make sure you know how to say it, what it's asking you for, so you're looking at the right thing and giving the right kind of answer. Okay, we good? All right, so when we go through the rest of these, everybody listen very carefully. Put your listening hats on. I want these completely factored, and I want the zeros, okay? Because some of y'all are stopping before it's actually factored all the way, and for some people, I think it's because you don't really know what you're doing, and for other people, you're just lazy, and I don't really know who's who at this point, but you need to be able to factor it all the way, so I want to see it. That's part of your answer, and then you do the rest, okay? So we're going to start with number 2, all right? So I'm going to start factoring this, and what's the GCF here? X. So I get x times 2x squared minus 5x minus 3. Now, remind me that when we factor, I asked you this and then I forgot what y'all's answer was. What you liked better, was it the grouping or was it the divide and slide thing? Grouping was more your thing. Okay. And that's what last period said too, but not all of them responded, so I wanted to make sure. Yeah, well, exactly. But I don't know what works for y'all because there's a lot of different ways. So we get negative 6, right? And then, but some of you aren't really doing your grouping correctly, so let's make sure we know how to do this. So we get 2x squared. I need two numbers that multiply to give me negative 6 and subtract to give me negative 5. Negative 6 and positive 1. So I get negative 6x plus 1x minus 3. Now, when you get to this point right here, make sure that these two numbers right here are going to add back to give you that right there, because if it doesn't, then you're already in a bad spot. Then I'm going to group these two together and these two together, right? So this is going to equal x, and then I'm going to put a bracket here so that I can keep up with this stuff. Out of these two, I factor out a 2x. That leaves me with x minus 3. Out of these two, what do I factor out? A 1. You got to factor something out, so we put plus 1, right? And then that leaves me with x minus 3. Right? That means that f of x is equal to x times 2x plus 1 times x minus 3. This is the fully factored form. Okay? Another thing you need to notice here in my work, you notice how my equal signs continued down here, right? It's okay that I didn't rewrite f of x on the left every single time. You can, but you don't need to. But you need to keep the fact that these are equal, and then at the end you can pop that back on. But don't just have random stuff everywhere. Now we give the zeros, right? And what's the smallest one? Negative 1/2, then 0, then 3. Everybody okay with that? Yes? All right. Oh, shoot. There we go. Okay, so then here, this is a quartic, but I can treat it like a what? Like a square, like a quadratic. But when you do that, pay attention to your exponents, because I think some of you know to do that, and then you're doing weird things, you're not writing the right exponents, then you confuse yourself. So when I do this, and I'm going to factor this into two binomials, this is going to be x squared and x squared. Since this is positive, I know that the signs are the same. Since this is negative, they're both minus. And so what are the two numbers? Minus 5 and, no, not minus 5. Liar, confuse me. They're going to have to multiply to give me 4 and combine to give me 5. 4 and 1, yeah. Okay. Now, can I factor this some more? Yes. This factors into x plus 1 times x minus 1, and this factors into x plus 2 times x minus 2. F of x. So then my zeros, this is going to give me a negative 1 and a positive 1. So it's going to give me plus or minus 1 and plus or minus 2. Easy. What questions do you have? Anything? Absolutely nothing. All right. So let's look at 4. So this is another quartic, but I can treat it like a quadratic, but A is not 1, and I don't have a GCF. So 9 times 4 is 36, right? And this is going to give me, oops, I guess I don't need to do that just yet. We want to do grouping, right? So I need two numbers that are going to multiply to give me 36 and combine to give me negative 37. There you go. So 9x to the 4th minus 36x squared minus x squared plus 4. Right? So then I'm going to group these two together and these two. This is going to give me 9x squared times x squared minus 4. And then what do I factor out of these two? Negative 1. Good. And this gives me x squared minus 4. Then that means I get 9x squared minus 1 times x squared minus 4. That 9x squared minus 1, can I factor it some more? Is it a difference of squares? Yes, it is. I can take the square root of both. So this is equal to 3x plus 1 times 3x minus 1 times x plus 2. Good, thank you. X minus 2. It's okay. That comment was actually an appropriate one he made. So we don't want to squash those. All right, so this is plus or minus 1/3 and plus or minus 2. Well, if you want to do it the other way, I don't care. I'm not saying you have to. I'm just trying to pick one where people would get. All right. So on the back here, let's see, which ones do I want to do? We're going to do number 6. All right, so number 6 is a cubic. Is there a GCF? No. And is it the sum or difference of cubes? No. Which means I have to do something else, which is what? Yes, I have to factor. But I have 4 terms, so what can I use? Grouping, okay? I can use grouping. Just like we took the trinomial and split it into 4, so I can use grouping here. I know. All right, so out of these first 2 terms, what can I factor out? 4x squared. Okay, good. 4x squared. So 4x squared times 5x minus 3. And then what do I factor out of these 2? Negative 1. That leaves me 5x minus 3. So when you do this, remember these 2 things in parentheses have got to match. So this equals 4x squared minus 1 times 5x minus 3. Thank you. Difference of squares. This is equal to 2x plus 1 times 2x minus 1 times 5x minus 3. And this is f of x. Boom. So I get out of here plus or minus 1/2. What does this one give me? 3/5. Good. All right, everybody okay with that? Okay, factor, factor, factor. Got to be able to factor quickly and accurately. All right, so now we're going to look at multiplicity. All right, the multiplicity of a 0 is the degree of its corresponding linear factor. We've already kind of looked at that when we sketched on Friday, right? If we had multiplicity, then that meant that we either had a bounce or a wiggle. Yes, no little exponents there. So we're going to find the zeros below and just state their multiplicities, like how many there are of them. So here, when we factor this one, what can I factor out first? X. So that leaves me with x squared plus 10x plus 25. Now, do you notice anything about this trinomial? Yes. This is a perfect square. Yep, I can take half of this and square it, and I get that number. Now, just because this is a perfect square doesn't necessarily mean that that's always going to work, but you check it, and it does, which means this is x times x plus 5 squared. That's completely factored. And then we are going to state the zeros and their multiplicities, so we're not going to do it in set notation. The smallest one I have is -5, and the multiplicity there is 2, because there's 2 of them. See, -5, and that's squared, so there's really 2 of those factors there. Okay? And then x equals 0, the multiplicity there is 1. Because it's going to tell us things. It tells us what's going on with the graph. Don't roll your eyes at math. All right, so then let's look at number 8. What can I factor out first? Negative x squared, because we would like for that to be positive. So negative x squared, that's going to leave me with x squared minus 6x plus 9. All right? So again, perfect square. If I take half of this and square it, I get 9, so that's good. That means I get negative x squared times x minus 3 squared. So my zeros, I get x equals 0. What's the multiplicity? Oh, multiplicity is 2, and x equals 3, and the multiplicity is 2. Okay, so those are part of my answers. Okay, we good? What questions do you have? Because it's x squared. Okay. What else? Anything else? All right, so let's look at what this multiplicity tells us for the graph. We've already kind of looked at this, but we didn't look at it in this form. We just looked at it on the graph itself. Okay, why can't I? There we go. So it says we're going to write this in factored form. So I'm going to rewrite this over here and we'll factor it real quick. X cubed plus 4x squared plus 4x. So this gives me x times x squared plus 4x plus 4. That means I get x times what? X plus 2 squared. So f of x is equal to x times x plus 2 squared. Right? So what we talked about on Friday is that when the multiplicity is even, that's when we have our bounce, right? But what's the real word for that? How is it related to the x-axis? It's tangent, good. The graph is tangent to the x-axis, and that is your bounce. Okay. If when the multiplicity is 1, nothing fancy happens. It just passes through the x-axis at 0. We can't say it intersects because it intersects when it's tangent also. And then when the multiplicity is odd and greater than 1, okay, so not 1, because when 1 it just passes through, then that's our wiggle. What's the real word for that? No.
Oh, wait.
Point of inflection. So it's a point of inflection. Not infection, there's an L there. Inflection. Which means then here, our zeros, I have one at 0, and then I have one at -2, right? And this is an odd function. It's a cubic, and so it's going to have the cubic end behavior. And I know at -2, that's where that tangency is, so it's going to come up and look like this. Comes up, and it bounces off, and then it comes back through, and the graph looks something like that. Okay. Michael would like to know if any of y'all have any questions. He's willing to answer. Oh, it was Rigo. All right. So let's look at this down here. So number 9 is already factored for you. All we have to do is we have to come up with our zeros. So the smallest one here is what? -4. Then 1, and then 3/2, right? So my zeros are -4, 1, and 3/2. What's the multiplicity of -4? 1. What's the multiplicity of 1? 2. And 3/2 is 2. Okay, so the effect when the multiplicity is 1, that's just a pass-through. Just passes right through the axis. When the multiplicity is 2, that's a bounce. What's the real word? Tangent. And this is 2, so this is also tangent. Okay? Everybody okay with that? Because this is going to be really important when we go to start graphing our rationals and stuff as well. All right, so go ahead and you work on number 10 while I pass out the assignment. You're going to have to factor it first. Yes. Yes. All right, see if you agree with me. Ask me questions if you don't. Okay. All right, any questions at all? All righty. Then go ahead and get this taped in. You've got lots of time to work, so make good use of your time.